Hey, I am a developer at some company, and this is Bit by Bit, a space where I explore, learn, and mess up, and sometimes grow also in the public as a developer. If learning tech in a simple and honest way is your thing, like, share, and subscribe. Let's take it one bit at a time. So, today we will learn about recursion, why recursion, why not recursion in detail, and yeah, I will explain the theory part mostly. So actually recursion is classic. So what recursion is, why we use it, and why not, the core theory, the case, the recurrence, the recursion stack, and everything we will go just in details. But let's take the first step. So why recursion? So I guess recursion is the most basic concept in programming. If you are familiar with then it is nothing. It is like a function calling itself until a base condition is achieved. So how simple it is. So someone can say recursion is a method where a function solves a problem by calling itself on a small instance of the same problem. A lot of definition can be made from this. Okay, but what's the most important thing is here that there is a base condition and there is a function, and what function do, it calls itself. So yeah, so that's why I choose recursion, because it have a more simpler definition. It is less complicated, but people won't get it at the first time. They will, because this is a concept. What's the problem between a concept and may seem tough to them? So okay, so let's come back to the topic. So yeah, recursion is a technique like where a function solves a problem by calling itself on a small instance of the same problem. Okay, let's say I have a problem. I want to add 5. I want to add I want to print 5 times 1. Okay, let's say I have this question. Okay, it's a simple. I have to print 1 5 times. I can write it 1 1 1 1 1. Okay, so I have to do this. So first thing what I can do, I can have a main function. I can write a we have to basically write a program for this. Okay, so the simpler program everybody knows if you are familiar with C++ syntax. Okay, so what we can do, we can call a main function. We can run a loop for I equal to 1 to I equal to 5. Okay, we can print I or 1. Okay, so this is the first method. Okay, now what would be the second method? How we will think this. So this is a basic, this is a simpler. We know if we have to print something 5 times, we will go on loop 1 2 3 4 5 and we will print 1. Okay, this is simpler. Now what's the new concept? The recursion says that if you have to print 5, then why you not repeat the function print 1 5 times? Okay, so it is basically the recursion. So what recursion says here, 5 times 5 times call the function print 1. Okay, so what print 1 do? Now what print 1 do? Print 1 is, it prints 1. It's simple, yeah, it prints 1. Okay, so what will happen if I will call this function 5 times, then 5 times it will print 1. Okay, then 1 1 1 1 1. Okay, so the concept is simple. So basically breaking up the problem into the most simplest tenses and calling it again and again to solve a bigger problem, it is called recursion. Okay, okay, so but converting this problem to this using recursion concept to this smaller problem, this is what people find tough. Okay, and yeah, nothing can be done about this. This can be achieved using practice only. So we have to do practice. We have to practice a lot of problems to basically apply that concept in the real problem itself. Yeah, so in recursion we will go through terms, we will go through some terms. Okay, it's like key based condition, recursion tree, yeah, stack space, what else, stack workflow you can say. Yeah. So when a function call itself, okay, we need a condition where the calling of function should get stopped. Okay, we can take this example. Okay, we are doing print 5 times calling the print 1. So if we are calling 5 times the print 1, okay, then how we can write an internal function. Let's say we have main. Okay, we have main, we have to we have to make a function f something, like you can say, yeah, print 5. This is our function. Okay, let's say. So what we want to achieve by this function, that it should print 5 times. Okay, why not int, we can discuss this thing later. Okay, so this is the name of function print 5. Or so okay, we had print 1. Okay, so 5, print 5, what we will do, it will call print 1 5 times. Okay, so what we can have, okay, we can have a variable here. Okay, simply term int k equal to 0, and we will pass k here. Okay, and what we will do, we will increase it. So basically this condition of loop I equal to 1 to 5, this will come here, and if k equal to 5, we don't want to call this function again, else call this function again. And what this function do, this function will just simply print 1. Okay, so this condition here, okay, this will call L base condition. So what happens generally? We have a function print 5. Okay, then it call again another function print 5, and what print, and it output is 1. Then again it calls function print 5, and output is 1 1. Same, it calls print 5, output is 1 1, and so on. Okay, so now this print 5 will call till 5. What's the value of k here? K equal to 0, k equal to 1. Here k equal to 2. It will go till 5 and it will break afterward. Okay, so yeah, this is a base condition, k equal to 4. Okay. And what is recursion tree? This tree we have maintained print 5 print 5. This we can have arrow here. Okay. Like it is calling this is calling this is calling this, and this will be recursion tree. So yeah, a function a calling itself a, calling itself a. This is the diagram. The diagram is set as a recursion tree. Okay, base condition, the condition where the function calls end up, alternate, and produce a result. Okay, stack space. Okay, so this print 5. Okay, we can have like this. Where okay, yeah. So let's say print 5, the first print 5 is called, and we have gone through this line. Then it will go, k would be 1, k equal to 4, no, k not 4, then it will print 1, then it will call print 5. Now this function waits at line 2. Okay, so what happens? Print 5 is waiting at line 2. Now it will go again, call print 5. It will go again, k would be 1, then k equal to 4, no, c out 1, yeah, it printed 1, k equal to 1, now print 5. Now again the previous print 5 is waiting. This print 5, first print 5 was waiting at line 2. Now this print 5, which is called here, now it will wait. We can use dash symbol. Okay, it is the same function, but we will use dash symbol. Okay, inverted comma symbol 2. Okay, and same where like this, yeah, and etc. So yeah, this space is actually built internally, and it is managed by our compiler. You can see it is built in area. It is built internally. So this is called stack space. This is basically a stack, internal stack, which every function have a corresponding memory, if you know about process and thing, then every function is assigned every program is assigned a memory, basically a stack memory. This will be print, but this is a like it is not a heap yeah, it is a heap memory kind of. So yeah, you can learn about this thing. So this is called stack space. let let's say, what if we forget the base condition? Then recursion will run indefinitely for infinite time, and it will give stack overflow or segmentation fault. Let's say if we forget this condition, yeah, k equal to 0, then what will happen? This print5 will call again another one, again another one. This will go on and go on, and previous function will always be in waiting state, and there would be a time come when this internal stack is occupies space, because it have variable, so it, yeah, of course, occupies stack. Then there will be no memory left, and no input can be added to the stack. Then we will get stack overflow error. Generally it is named after like segmentation fault. We will get segmentation fault error. So yeah, this is all about recursion. This is the theory part. We will cover more problems, and we will discuss it like in detail about those problem, how because thing can be learned through application and problems only. Yeah, so thank you for all.